So I got obviously a TIG welder here, a new one, and I'm learning how to TIG weld. And as you can see from this tip, there's lots of dipping going on, lots of electrode sharpening happening. So I watched a few videos. Stefan Gotzwalder has one that's really good, where he made a slow spinning tungsten, kind of general purpose tungsten grinder. And my first thought, I have this old peerless knife sharpener, and the motor went up. It shorted out and gave me a little jolt, so I had to get rid of that. So I was thinking, you know, maybe I could use this and adapt the shaft. And you know, watching those videos from Stefan and Build Something Great, I don't remember his name. Anyway, watching the video from some other folks who have built them, you know, I thought I could adapt this, and I remembered I don't have a motor for this right now. So I have a few options. One of the options I had was I have some servo controller motors that are 24 volts. I thought about doing that. I've got some gear motors that are also 24 volts that are pretty slow RPM. Then I remembered I saved this old garbage disposal. This is a Badger 5, and the motor works great, but obviously it was rusted out and leaking. So I took it apart last night. There was a bolt on here that I ground off. I pulled this whole thing off, and you know, I was thinking I could 3D print a housing and mount a bearing in here that would keep the arbor centered. And I should have a decent motor, and then I could make a, you know, put some permanent Loctite on here with a long, make a shaft extension. The problem with this is that these things get pretty warm, and if you're going to 3D print, even if you do like PETG or ABS, you really can't get above 90 degrees Celsius. So I'd really need to have something metal to hold the bearing, because the heat's just going to soften the 3D printed material, and then the whole thing will go crashing into the stator, will crash into the windings here. That won't be any good. So I thought that was a little overcomplicated. And then I remembered, you know, I have a Harbor Freight belt and disc sander, and I kind of recall that this wasn't all that complicated. I mean, it's just a piece of aluminum. There's a 10 millimeter hole here and an 8 millimeter grub screw, and I have some pretty big stock. So I had this stuff, and this is a pretty big chunk of aluminum. This is 3-inch, 76 millimeter, and so I thought this was, you know, roughly the wheels that I got based on Stefan's advice were 100 millimeter or 4-inch diamond wheels, and this is 3-inch. I figured they're stiff enough that the 1/4 inch of overhang isn't going to really necessarily cause any problems. So I figured I'd take some 3/4 inch and weld it on here to save a bunch of material. It'd also give me a good opportunity to see how many times I could dip my electrode in a giant puddle of molten aluminum. So that's what I did. I went ahead and made this thing, and we'll go ahead and step over to the computer, take a look at the model that I mocked up. I didn't actually make any drawings. I just kind of winged it out of, you know, a bunch of different pieces that I had, a bunch of scraps that I had. This is the only piece of stock that I used for the whole thing. The rest was salvage from the scrap bin. So I hope you enjoy it, and maybe you'll get some mileage out of a similar idea. So here's a quick drawing that I made of the, whatever I want to call it, the tungsten grinder. Essentially, the gold piece is the disc. It's 100 millimeters. I've got an M5 bolt, and I have a kind of a washer that fits the 16 millimeter inner diameter of the diamond wheel there, and then that seats down into this piece of, I don't even know how big this is. I think it's about 90 millimeters. And then I took a piece of, I think, 19 millimeter scrap aluminum that I had, and I just put I put a chamfer here, and then I put a big fat fillet weld right here and right here. And then this is steel, and this is steel. And I think I made this whole, I want to say I made this whole 8.5 millimeters. And I had a piece of scrap for this piece. So I think the diameter of this is 9.5 millimeters. So I welded this up. I bored this part out to 10 millimeters and reamed it. And then this part is, I think, 8.5 millimeters. And then the bolt just secures it, and these two steel pieces kind of clamp together. And to secure this steel piece to the aluminum body, I just used some CA glue. I don't know if that's going to hold up, but I can use some permanent Loctite if I have to. That's the part that I made. There's also a M8 grub screw that attaches to the Harbor Freight disc arbor.
I lose all that footage? Damn it.